Okay, in today's video, we are going to talk about the derivative from first principles. This is grade 12 calculus, lesson 1 of 6. Okay, let's say you have this, the graph of f, and you are required to find the gradient of a tangent line which is touching this graph of f at a point. Okay, from what we know how to find the gradient of a line, right? So we are going to use what we know previously. Okay, so let's say you have this line which is cutting the graph of f at this point. Okay, let's call this point point P, and it's also cutting the graph of f at this point. Let's call this point point Q. Okay, so this line is known as a secant, okay, because it's cutting this curve in two parts. Okay, a secant is a straight line that cuts a curve in two or more parts. Okay, this is a secant. You need to have any 2 points on a straight line so that you can find the gradient of that straight line. Okay, so we are going to use that knowledge, and from that knowledge we are going to see how to find the gradient of a tangent. Okay, you know that a tangent is a straight line that touches a curve at one point. Okay, is a straight line that touches a curve at one point. Okay, for now we have this secant. Okay, so let's use the knowledge that we know about finding the gradient of a straight line. Okay, so this straight line is cutting the graph of f at point P and at point Q. Okay, so these points, they have their coordinate. Okay, so point P has got the x coordinate, right? Let's call it x. For now, let's call it x, and the y coordinate will be f of x. Okay, f of x. This is the y coordinate, and this is the x coordinate. And point Q has got the x coordinate and the y coordinate. Okay, from x, the next value, let's call it x plus h. Okay, so x plus h is the x coordinate of point Q. Okay, so this is like from -3 to -2. Okay, the next value. So you need to add some value from x to get the next value, which is x plus h. Okay, the value that is added to get the next value is h. So the y coordinate of point Q will be f of what? F of x plus h. Okay, so this is the y coordinate, f of x plus h. Okay, so you have the difference between x and x plus h is h. Okay, so h is the value which is added from the previous point on the x-axis to get the next point on the x-axis. So to find the gradient, you know that you need the change in y and the change in x. Okay, so the change in y is f of x plus h minus f of x. So this is f of x plus h minus f of x, okay, over the change in x, which is x plus h minus x. Okay, x plus h minus x. Okay, the change in y over the change in x. So this is equal to, you have the change in the y, okay, which is this, over, you can see x minus x, this is 0, you remain with h only. Okay, so this is equal to the average gradient. Okay, so we call it the average gradient because the gradient keeps on changing on the graph of f. Okay, now we are going to use this knowledge and see how we can find the gradient of a tangent. So you still have your graph, the graph of f, right? And you have point Q right there. You still have the same coordinate, x plus h and f of x plus h. Okay, x plus h, the x coordinate, and f of x plus h, the y coordinate. Okay, you know that a tangent line is going to touch this curve only at one point. So what we are going to do is to take point P and move it and get it exactly above Q. Okay, so when you move point P and you get it exactly above Q, this is what you get. Okay, so you are going to have this line which is touching the curve at one point only. Now this is a tangent. To get the gradient of a tangent line which is touching this graph of f at one point, at that point, we're still going to use this formula, but we have to make some change so that it can be the formula for the gradient of a tangent line which is touching the graph of f at one point. So this is what we have for this, right? You have the change in the y over the change in the x. Okay, so now we have to introduce something so that this gradient can be the gradient of a tangent line, right? So you have to notice something. In the previous sketch, you can see you have the change from x to x plus h, right? The change is h, you can see. Now, in this drawing, you don't have that change, right? Because you have point Q and point P exactly on top of each other. The change is equal to 0 in this drawing. So we are going to introduce this. We are going to say the limit as h goes to 0. This is why we have to introduce the limit as h goes to 0 so that we can get the gradient of this tangent line which is touching the graph of f at one point. So this is why we have this, the limit as h goes to 0. Okay, so this is equal to the gradient of a tangent line at any point on the graph of f. Okay, and so this is equal to f prime of x. So this is the formula that you can use to find the derivative from first principles or to find the derivative using the definition. They can say find the derivative from first principles or find the derivative using the definition. Okay, so this is what? This is the gradient of a tangent line that is touching a curve at one point. Okay, now question 1. Determine the derivative from first principles if f of x is equal to x squared plus 3x minus 5. Okay, so when they ask you to determine the derivative from first principles or determine the derivative using the definition, they want you to use this formula, the one we saw in the previous slide. Okay, so let's carry on. F prime of x, or the first derivative, is equal to the limit as h goes to 0 or as h approaches 0. So now you have f of x plus h minus f of x. Let's start with this f of x plus h. So you are going to take x plus h, you plug in there. Whenever you see x, you substitute x plus h. Okay, so you have x squared. You are going to remove this x, you put x plus h squared, right? Now you can see you have x plus h squared instead of x squared, right? Remove x whenever you see x and put x plus h. Okay, let's carry on. You're going to have plus like this. Okay, remove x, you put x plus h, and then you have minus 5. Okay, so let me close everything inside the square bracket like this so that I don't confuse what I'm doing. Okay, so let's carry on. You have minus, and now after you finish with x plus h, now you are going to take x, you plug x in there, you remove x, you put x, this x in there. So you are going to end up with the same thing. When you remove this x and you put this x, this is what you get. The same thing. Okay, so this is over h. You carry on. F prime of x, or the first derivative, is equal to the limit as h goes to 0. Okay, so you have x plus h in bracket squared. Let's expand the bracket So you are going to have x squared, and you have x times h times 2. Okay, so you are going to have 2xh, right? Plus 2xh. And you have plus h squared. Let's carry on. You have plus 3 times everything inside of the bracket. You are going to have plus 3x, and then plus 3h, plus 3h, and then minus 5. Okay, you have minus in front of this bracket. Everything inside of the bracket are going to change the signs. Okay, so you are going to have minus x squared, and then minus 3x, and then plus 5, because you have a minus in front of the bracket. Okay, so this is over h. Now you have x squared minus x squared. This is 0. And you have 3x minus 3x. And you have minus 5 plus 5. This is equal to 0. So you remain with this and this and this. Okay, you only remain with the terms having h in them. Okay, let's carry on. F prime of x is equal to the limit as h goes to 0. You have 2xh plus h squared plus 3h, right, over h. Now you are going to factorize h outside of the bracket so that you can cancel with this h at the bottom. Okay, so f prime of x is equal to the limit as h goes to 0. You factorize h outside of the bracket. You remain with 2x plus h, right? And then plus 3 over h. So this and this, they cancel. You only remain with this. You carry on. F prime of x is equal to the limit as h goes to 0. So you only remain with this. Now you can substitute 0 for h. Okay, so when you substitute 0 for h, you are going to drop this part. Okay, so this is the only time you are going to drop this part when you substitute 0 for h. Okay, so f prime of x is equal to, you drop this part, you substitute 0 for h. So whenever you see h, you plug 0 in there. So you are going to have 2x plus h. So 0 for h, you have plus 0. And then plus 3, f prime of x is equal to 2x plus 3. Now let's move on to question 2. Question 2, determine the derivative from first principles if f of x is equal to this 3 over x. Okay, so now you have a fraction. How can you determine the derivative from first principles? Okay, whenever they say determine the derivative from first principles or determine the derivative using the definition, they still want you to use this formula, the formula that we saw in the previous slide. Okay, f prime of x is equal to the limit as h goes to 0. So you start with this x plus h, you plug in there. Whenever you see x, you remove the x, you put x plus h. Okay, so we start with x plus h. You're going to have 3 over x plus h. Let me put this inside a square bracket. You have minus there. Okay, let's carry on. You have minus there. You take now x, you plug in there. Whenever you see x, you plug this x. So you are going to have the same thing, 3 over x. Okay, so this is over h, right? Let's carry on. F prime of x is equal to the limit as h goes to 0. Now you have two fractions. You can see you have this fraction and you have this fraction. So we are going to take the lowest common denominator, which is x times x plus h. The lowest common denominator, x times x plus h, right? So when you take this, you divide by this, you're going to remain with x. So x times 3, you have 3x, you have minus, you take this lowest common denominator, you divide by x, you're going to remain with x plus h. You multiply by 3, so you have 3 times x plus h, right? This is over h. So now you're going to get rid of this. You can do that. You get rid of this. So to get rid of this, you have to multiply by 1 over h so that you can cancel, and you are going to remain with 1 at the bottom. So what you do at the bottom, you also do at the top. So you are going to multiply this by 1 over h. The purpose is for you to remain with 1 at the bottom. So this is going to cancel. You only remain with 1. So let's carry on. F prime of x is equal to the limit as h goes to 0. Now you have 3x times 1. It's 3x. You have minus 3 times x and then times 1. Right? Minus 3 times x times 1, which is minus 3x. Let's carry on. You have minus 3 times h times 1, which is minus 3h. Okay, minus 3h over, you have x times h. So you have x squared h. X squared h. You have x times h, which is x h squared, right? Plus x h squared. So this is what you have. You can see you have 3x minus 3x. This is 0. You have f prime of x is equal to the limit as h goes to 0. You have minus 3h at the top over f prime of x is equal to the limit as h goes to 0. You take h outside of the bracket. You remain with negative 3 over, you take h outside of the bracket. You remain with this, right? You remain with x squared plus xh when you take h outside of the bracket. So you have this. You can cancel. F prime of x is equal to the limit as h goes to 0. You have negative 3 over this. Okay? Like this. So can you substitute 0 for h? When you substitute 0 for h, you're going to have this equal to 0. So you are going to have x times 0. You can see you are not going to have division by 0 because you still have this. This is not going to be 0. So you can substitute 0 for h. You are not going to have division by 0. So f prime of x is equal to, you have this negative 3 over x squared plus 0, right? This is 0. When you substitute 0 for h, this is 0 plus x squared, right? X squared plus 0. So this is not division by 0 because you don't have only 0 at the bottom. So it is possible to substitute 0 for h at this step. Okay, so this is possible. So this is equal to negative 3 times x to the power of negative 2. When you take x squared to the top, now it becomes x to the power of negative 2. Okay, so this is the final answer. Now we are going to see the last question, question 3. Okay, let me do that on the next slide. Okay, now the last question, question 3. Determine the derivative from first principles if f of x is equal to x cubed minus x squared. When they ask you to determine the derivative from first principles, they want you to use this formula. Okay, you know that. F prime of x is equal to the limit as h goes to 0. Okay, you start with this. You are going to take x plus h. You plug in there. Whenever you see x, you remove x, you put x plus h. So you are going to have x plus h cubed minus x plus h squared, right? So this is what you do. You are done with this. You can put everything inside the square bracket so that you don't confuse. Okay, let's carry on. you have minus there. Now, after you are done with x plus h, you are going to take x. You plug in there. So you are going to remove this x. You put this x. So you are going to have the same thing. So you're still going to have the same thing. This. Okay? I hope you understand so far. This is over h. Let's carry on. F prime of x is equal to the limit as h goes to 0. Now, you are going to expand the bracket. Okay? So you have this first bracket, x plus h cubed. You have your square bracket. So I'm going to expand this bracket. Let me show you how you can expand this bracket. So you have x cubed as your first term, and you have h cubed as your last term, and in between you have 3xh and 3xh. You still have your plus there, right? So I'm not done with the powers. I'm going to show you how you can expand this bracket. When you have x plus h cubed, this is how you can expand. We are not done. So you have x cubed as your first term and h cubed as your last term, and in between you have 3xh and 3xh twice. Okay, now your powers. You start with x cubed, right? You can see you start with x cubed. The next power of x is going to be x squared. Okay, from 3 to 2, and the next one is 1, x to the power of 1. You do the same with h. From right to the left, you start with h cubed. The next one will be h squared, and the next one will be h to the power of 1. Okay, so you are done expanding this bracket. Okay, or if you want, you can use the long method. You know that x plus h cubed is equal to this times this times this 3 times, right? Like this. So you're still going to have this as your final answer. Let's carry on. You have minus there. Now you are going to expand this bracket. You have x squared, right? X squared, and you have x times h times 2, which is 2xh, right? X times h times 2, which is plus 2xh. And you have plus h squared plus h squared. You close your round bracket and you close your square bracket. You still have minus there, and you have this, okay, over h. Let's carry on. F prime of x is equal to the limit as h goes to 0. You have x cubed plus 3x squared h, 3x squared h plus 3x h squared, 3x h squared plus h cubed. You have minus in front of this bracket, so you are going to have minus x squared minus 2xh minus h squared. You have minus in front of this bracket. You're going to have minus x cubed plus x squared. Okay, because you have minus in front of the bracket. This is over h. Now you have x cubed minus x cubed. This is 0. And you have minus x squared plus x squared. This is 0. You only remain with the terms having h in them. This and this and this and this and this. So f prime of x is equal to the limit as h goes to 0. You have this and this and this, okay, and this, right, and this over h. Okay, now you can factorize h outside of the bracket so that you can cancel with the h at the bottom. So f prime of x is equal to the limit as h goes to 0. You take h outside of the bracket. You remain with 3x squared plus 3xh plus h squared minus 2x minus h. You close the bracket over h. Now you can cancel. Okay, so this is equal to, you remain with this. Okay, now you can substitute 0 for h. So f prime of x is equal to, when you substitute 0 for h, you are going to drop this part. So you have 3x squared plus 3x times 0, right? You substitute 0 for h, you carry on, you have plus 0 squared minus 2x minus 0. Okay, we carry on. F prime of x is equal to 3x squared. This is 0 plus this is 0. You have this minus 2x. This is 0. So this is your final answer. You can see if you use the laws of differentiation, you're going to have 3x squared minus 2x as you have it. So we are done with lesson 1 of 6. Please check for lesson 2 of 6, which is on the laws of differentiation or the rules of differentiation. For now, we are done. Until next time, I will talk to you soon.